Alright, this lesson deals mostly with proving what kind of quadrilateral we have using distances and slopes that we can find. We are going to be referring to this quadrilateral flowchart, and this is what I want you to use when you're trying to decide what quadrilateral you are looking at. Start by asking yourself, is it a parallelogram? You know what I mean? Are opposite sides congruent? Are opposite slopes the same? So first you will ask yourself, is it a parallelogram? Is it a trapezoid? Is it a kite? You know, of course, we're talking about these things: parallelogram, trapezoid, kite. If it is a parallelogram, then you will decide, can you go more specific and call it a rectangle or a rhombus? If you decide it's a rectangle, you want to go further and ask yourself, wait a minute, is it a square? Alright, same thing with a rhombus. Alright, if you decide it's a trapezoid, you're going to ask yourself, is it isosceles? If you decide it's a kite, you know, one of these, then that's the end of the road. A kite is a kite. There's no special case for that. So keep that in the back of your mind as I go over this. So looking at problem number 1, I just plain gave you the distances and the slopes, you know, the lengths of all the sides and the slopes. So all the lengths were 8. So in terms of is it a parallelogram or not, the definition of a parallelogram is that the opposite sides are parallel. But we also know that opposite sides of a parallelogram will be congruent. So as soon as you look at this, you see that, well, all of them are the same, but that does mean that opposite sides are the same. If I do look at the slopes, -5, 4, 4. The opposite slopes are also congruent. So it's definitely a parallelogram. But like I said, once we decide it's a parallelogram, not a trapezoid, not a kite, we have to go further and say, wait a minute, is it a rectangle or a rhombus? Because that would be more specific. Well, what's a rhombus? A rhombus has 4 congruent sides. So we see that it does have 4 congruent sides, so that tells us that it is a rhombus. Wait a minute, okay, maybe it's a square. That's the last thing you need to check. We know it's a rhombus, but because it has 4 equal sides. A square has 4 equal sides. So what's special about a square, though? A square not only has 4 congruent sides, but a square has 4 right angles, 4 90-degree angles. So is it a square? Well, these slopes tell us that it's not a square. Now remember, in case you forgot about this, the way we know if we have right angles or not, if these consecutive angles are going to be 90 degrees, then these sides should be perpendicular. Remember how perpendicular works? If the first slope is -5, the next slope should be 1/5. See how these are opposite sign, negative and positive, and reciprocal. This is like 5/1, 1/5. If you have opposite reciprocals, then that's how you know this would be a 90-degree angle. But these are not opposite and reciprocal. So that's how we know this is not a square. There are no 90-degree angles here. So it's not a square. That means we have to just stop at rhombus. So rhombus is the most specific thing we can say. So as far as your explanation, once you decide it's a rhombus, you're going to start your explanation by saying this is a rhombus because, and then I want you to say the definition. On this page of quadrilaterals that's showing the definitions and the special properties of my quadrilaterals, the definitions are all in yellow. So for rhombus, the definition is it has 4 congruent sides. So when you do your explanation, I want you to say this is a rhombus because it has 4 congruent sides. Okay, looking at problem number 2. You see these slopes, you see these distances. The first thing you should do is ask yourself, is this a parallelogram? If it's a parallelogram, the opposite sides should be parallel, meaning same slope. So, undefined, undefined, those are the same. So far, so good. But look at QR and PS, 1/4 and -1/4. These are not the same. So that means this cannot be a parallelogram. So right there, we know it's not a parallelogram, which means it's none of these things. It's not a rectangle, it's not a rhombus, it's not a square. So we slide on over, ask ourselves, is it a trapezoid? Remember what a trapezoid is. All right, trapezoid looks like this. The definition of a trapezoid is it has exactly one pair of parallel sides called bases. Okay, you see that right here? So a trapezoid, exactly one pair of parallel sides. So look at our slopes again. Remember, if sides are parallel, they should have the same slope. Undefined, undefined. Those are vertical lines, by the way. But they are parallel. That's one pair of parallel sides. And we already talked about the fact that the other pair is not parallel. So it does have one pair of parallel sides. That means that it is a trapezoid. Okay, the only question now is, can we go more specific? Is it an isosceles trapezoid? Okay, it's a trapezoid, but is it isosceles? Now, what is an isosceles trapezoid? An isosceles trapezoid is a trapezoid that has one pair of congruent sides. The legs. If you're looking at a trapezoid, the parallel sides are called bases. So like that's a base, that's a base. The non-parallel sides are called legs. So that's a leg, that's a leg. If it's isosceles, the leg should be congruent. So look at the sides that are parallel. Those sides that are parallel are the bases. So I know that this is a base. Okay, you know what I mean? PQ is a base and RS is a base. These are my bases. So let me switch colors. If those are my bases, because those are the ones that were parallel, that means that these two must be my legs. So that's a leg and that's a leg. If these legs are congruent, it will be isosceles. Radical 17, radical 17. The legs are congruent, so that's like your congruent legs right here in this picture. So that's why we know this is not only a trapezoid, it is an isosceles trapezoid. When you do your explanation for isosceles trapezoid, you have to basically mention two things. You have to say why it's a trapezoid first, and you have to say why it's isosceles. So it's an isosceles trapezoid because it has exactly one pair of parallel sides, that made it a trapezoid, and the legs are congruent, that made it isosceles. Let's go on to number 3. Okay, so this time I didn't give you the lengths and the slopes, so you had to calculate those yourself. So one time, let me just remind you how we do these calculations. But after that, I'm going to leave it to you to do your own calculations. Alright, so here's where these numbers were coming from, just to remind you. If I want to find the length of AB, side AB, I'm going to use the distance formula. So AB, remember this is how the distance formula works. Okay, the distance formula is, you go x minus x squared plus y minus y squared. That's how you do the distance formula. So the distance from A to B is going to be the square root of, okay, so x minus x. So it's going to be like 2 minus 1 squared, and then y minus y. So that's -1 minus 3. So -1 minus 3 squared. Distance formula. If you just put all that in your calculator, we should get radical 17. Let's check that. So here I've typed in my square root of 2 minus 1 squared plus negative 1 minus 3 squared. See what we get. Oh, sure enough, radical 17. So that's where these numbers are coming from. Now, remember that the way we find slope, if I want to find the slope of AB, for example, okay, slope AB, remember the slope is like y minus y divided by x minus x. So using these same numbers, the slope, so y minus y, so that's like negative 1 minus 3. Okay, it's really the same thing that was right there. And then x minus x, 2 minus 1. See that 2 minus 1? Same thing. Alright, y minus y over x minus x. Okay, let's put that in the calc. I mean, you could do it by hand, but you know I'm going to do it by hand. Negative 1 minus 3 is negative 4. 2 minus 1 is 1. Anything divided by 1 is just itself. So we get negative 4. If you're bad with arithmetic, you can always put it in your calculator. But that's where the negative 4 is coming from. So doing calculations like that for slope and using the distance formula, that's where all the lengths came from. That's where all the slopes are coming from. Okay, I'm not going to do those calculations over and over again. I'm just going to assume that you can do that part accurately. Anyway, so for number 3, given the points on a coordinate plane, prove that ABCD is a parallelogram. This particular problem, we're told it's a parallelogram in the first place. We're just supposed to prove it. So we found all the lengths and we found all the slopes. Now, we have to do one more step. See this stuff that I'm writing here in blue? That's not optional. Looking back at our flow chart, okay, if we decide that something is a parallelogram, there's always a chance that it can be more specific and wind up being a rectangle or a rhombus or maybe even a square. So please remember this. If you decide that it's a parallelogram and you're going to stop at parallelogram and you're not going to go on and call it a rectangle or rhombus, you have to explain why you're stopping at parallelogram. You have to explain why it cannot be a rectangle and it cannot be a rhombus. Basically, if you're stopping any point on this flow chart, if there's anything below it, you have to explain why you're not going below it. Now, I just have to explain why it's not a rectangle and why it's not a rhombus. I don't have to explain why it's not a square, because there's no way it's going to be a square if it's not a rectangle or a rhombus. So I already covered it. So, why is it not a rectangle? Why is it not a rhombus? So looking back at the numbers, it's a parallelogram. Okay, we can verify that because look at the slopes. The opposite slopes are the same, that meaning these are parallel, and these are also parallel. And the opposite sides are the same length, congruent. Radical 29, radical 29, radical 17, radical 17. Fine, it's a parallelogram. But why is it not a rectangle, for example? Well, you have to circle these slopes because slopes like these are what tell me that it's not a rectangle. Remember, if it's going to be a rectangle, it should have 4 right angles. That's the definition of a rectangle. And remember that the way slopes work, if one side has a slope of -4, the perpendicular side should be a slope of 1/4. They should be opposite sign and reciprocal, things like that. Looking at these slopes, the first one is -4, all right? The perpendicular one should have been 1/4, but it's not, it's 2/5. So these are not opposite and reciprocal. That means these are not perpendicular lines. There's no right angle here. It's not 90 degrees. So that's how I know it's not a rectangle. So that's not optional. Circle these and write not a rectangle because of that. Now, why is it not a rhombus? All right, we said why it's not a rectangle. We have to also say why it's not a rhombus. Well, what is a rhombus? You know, the definition of a rhombus is 4 congruent sides. That's what a rhombus is. It's anything that has 4 congruent sides. So, looking at these lengths, I don't have 4 congruent sides. So I know it's not a rhombus. So all you have to do is circle 2 of the lengths and write not a rhombus, because we're showing that these 2 are not equal. So it can't be a rhombus. So that's why we just stopped at parallelogram. So as far as your explanation, you can just say this is a parallelogram because, and then go ahead and mention the definition of a parallelogram. The definition is opposite sides are parallel. So you're going to say it's a parallelogram because both pairs of opposite sides are parallel. Okay? Or you could have used congruent if you wanted to go with that special property. Number 4. Graph the given points on a coordinate plane. Given that Pqrs is a parallelogram, prove what type of parallelogram it is. Of course, show why it is not a more specific shape if one exists. So, again, we found the lengths using the distance formula, similar to what we did up here. And we found the slopes using the slope formula, y minus y over x minus x. So that's how I got all these numbers. Now, as always, we go through our flowchart. So first thing we ask ourselves, is it a parallelogram? If it's a parallelogram, opposite sides should have the same slope, because that would mean they're parallel. And they are 1/2, 1/2, negative 1/2, negative 1/2. Also, opposite sides are congruent. So it's definitely a parallelogram. But then we have to ask ourselves, is it a rectangle? Is it a rhombus? I look and I see, I'm looking at these slopes here, and I see that the slopes are not opposite and reciprocal. So I see the 1/2 is the first slope. If this were going to be a rectangle, the next one should be -2. All right, those would be opposite and reciprocal. But I don't see a -2. I see negative 1/2. So this is not a 90-degree angle. So right there, I know this is not a rectangle. Is it a rhombus? Well, look, I see the 4 sides are congruent. The definition of a rhombus is 4 congruent sides. So it's not a rectangle because of these slopes over here. But it is a rhombus. As soon as I see these lengths, I know it is a rhombus. So, looking at my flowchart, it was a parallelogram. I knew it was a rhombus because it had 4 congruent sides. But if I'm going to say it's a rhombus, I have to say why it's not a square. That's why on my chart here, I've circled these 2. And I kind of covered this when I said why it wasn't a rectangle. But now it's the same thing. To be a square, it had to have right angles, 4 right angles. And because these are not opposite and reciprocal, it is not a square. So that's what tells me down the flowchart, parallelogram, rhombus, but not square. It stops here at rhombus. Okay, and for your explanation, you say this is a rhombus because it has 4 congruent sides. Simply mention the definition of rhombus, 4 congruent sides. Moving on. Number 5, what type of quadrilateral is this? As always, we start with parallelogram. Then we'll move to trapezoid and kite. Is it a parallelogram? Well, if it's a parallelogram, both pairs of opposite sides should have the same slope because they're parallel. 0 and 0, that looked good. But -7 and 7, those are not the same. So it is not a parallelogram. So then I slide on over on my flowchart. I ask myself, is it a trapezoid? Definition of a trapezoid is it should have exactly one pair of parallel sides. Is that the case? Yes, I have my 0 and my 0. That's one pair of parallel sides. The others are not. So right there, I know that it is a trapezoid. So fine, it's definitely a trapezoid. Now I have to ask myself, but is it isosceles? All right, because that would be more specific. Remember, if it's isosceles, the legs should be congruent. Now, these are my parallel sides, 0, 0. That means this is a base, and this is a base. Okay, these are my non-parallel sides. That means this is a leg, and this is a leg. Are the legs congruent? Well, they are. 5 radical 2 and 5 radical 2. The legs are congruent. Okay, that means we're looking at one of these, an isosceles trapezoid with congruent legs. So we have to be as specific as possible, so we will call this an isosceles trapezoid. Again, you have to mention why it's a trapezoid and why it's isosceles. So it's an isosceles trapezoid because it has exactly one pair of parallel sides, that's the trapezoid part, and the legs are congruent, that's the isosceles part. Okay. The picture below is a rectangle. Which statement is accurate? This is really a silly question. And I accidentally made it have 2 answers that are correct. I guess the point is you needed to either do the Pythagorean Theorem or the distance formula to really prove what the lengths are of these sides in the first place. So just understand this, guys. If I make a triangle right here, for example, say if I make this triangle right here. See how that's a right triangle? If I count these squares, this is 4 and this is 3. So the reason I'm getting this 5 is because of the Pythagorean Theorem. If I do, say if this was x at first. If I do a squared plus b squared should equal c squared. So x squared should equal 4 squared plus 3 squared. If you take the square root of both sides, guess what? You get 5. So that's where this 5 is coming from. You could do the same thing with this bigger triangle. Okay, like this. Whoa, messed that up a little bit. Okay, you can do the same thing with this bigger triangle. But this is 6 and this is 8. Alright, if you do the Pythagorean Theorem, you get 10. So, fine, that's where you get these the sides from. Then it's just a matter of looking at it, okay? DC and BC. Well, DC and BC, let me erase this green stuff. DC is this shorty, but BC is one of the long ones. So, that's a 5 and a 10, not a 5 and a 5. They're not equal. Okay, so that's just silly. Once you get to option B, DC and AB equal 5. Well, yeah, there's DC, there's AB, they're both 5. So that's why that's an answer. DC and DA, DC is a shorty, DA is a long one. So they're not equal. But then look at D, AD and BC. Well, AD is 10 and BC is 10. So that is another true statement. Sorry about that. Okay. Last but not least, number 7. This is a rhombus. Which of the following is not always true? Which is not always true? That means 3 of these statements should be always true and one of them is not. Okay? Look, the key thing that messes kids up sometimes is you don't know all these properties. So one of the main special properties of a rhombus is that the diagonals are perpendicular. Okay, the diagonals are perpendicular. That's also true for a kite, by the way. But if you know that the diagonals are perpendicular, that's going to help you later. So just keep in mind that the diagonals, meaning like this and this, should be perpendicular. Anyway, this M stands for slope, and that's slope. So slope PQ is 2. Okay, so let's see, slope PQ, negative 2. If slope PQ is negative 2, then slope RS is negative 2. Is that always true? Sure. A rhombus is a parallelogram, so opposite sides should be parallel. So if PQ has slope negative 2, then RS will have slope negative 2 as well. So that's always true. That's why that one was out. Okay, we're looking for one that's not always true. So then we go to these distances, distance QR and distance RS. Okay, fine. If distance QR is radical 21, so here's QR, call it radical 21, does that mean distance RS is radical 21? That's this over here. Well, yeah, it does, because we're talking about a rhombus. And the definition of a rhombus is it has 4 congruent sides. All right, that's what a rhombus is. So if QR is radical 21, all the sides are radical 21, including RS. So that's definitely going to be always true. So that's not the answer. We're looking for the one that is not always true. If you look at C, back to slopes again. Okay, slope PR. Okay, so slope PR, that's one of the diagonals. Okay, so we got that slope happening. And then slope QS, we're given that. All right, so look at these green lines. Okay, these are the diagonals. The PR and the QS are the diagonals. So if one of them is slope 1/4, okay, will the other one always have slope -4? Well, the key is what I told you at the beginning of this problem. One of the special properties of a rhombus is that these diagonals are always perpendicular, 90 degrees. When lines are perpendicular, their slopes are opposite and reciprocal. Are these opposite reciprocals? Well, yes, they are. So this will always be true. If one line has slope of 1/4, since the other diagonal is always perpendicular, it will always have slope -4 to be opposite and reciprocal. So that's why C is always true. So that can't be the answer. So the answer must be D, but let's look at it carefully and try to understand why. If the distance, the length PR is 6. Okay, let me erase some of this garbage. Okay, if the length PR is 6, so that's this right here. Okay, let's say that's 6. Then the length DQ will be 6. Okay, the length QS, that would be this length right here. So in other words, they're saying, will the diagonals here always be congruent? Will these diagonals always be congruent? Well, if this was a square, then the answer would be yes. Okay? Because if it were a square, the diagonals would have to be congruent. But a rhombus, the diagonals of a rhombus do not have to be congruent. That's not one of the special properties. Think about it. This one I drew it almost like a square, but here's another example of a rhombus to make it more obvious to you. Okay, here is a rhombus. Check it out. All 4 of these sides are the same. So this could be my P and my Q and my R and my S. This is a rhombus. PR let's say that's 6. Does that mean that QS is going to be 6? No. Obviously, PR in this case is much shorter than QS. Okay, so the diagonals of a rhombus will not always be congruent. In fact, usually one will be shorter and one will be longer unless it's a square. So D is not always true. That's why it is the answer to this question. All right, and that's it for this homework lesson.